Okay, YouTube, in this video we're going to start our exploration of functions and their graphs. And before we can do any of this, what we need to do is we need to start with a definition of what we call a relation. Okay, so we say a relation is a set or any set of ordered pairs. We say the set of all first components of the ordered pair is called the domain, and the relation of the relation, and the set of all second components called the range of the relation. So we're going to be looking at a lot of different relations between data. We could say maybe time and maybe temperature as maybe a function of time or maybe not. But what we can do is we could express these as ordered pairs, where we say this first component is time and the second component is temperature. So noting these two words up here, domain and range, it's very important that we recognize that we refer to the first component as the domain component of this relation. We say that this is the range component of the relation, or the output component. So for this first example here, it just says find the domain and range of the relation. Well, what I notice is I've got a set of ordered pairs, and all of the first components here, the set of those is going to be the domain components. We say 0, looks like it's going up by tens here, 0, 10, 20, 30, and 40. Those would be the set of our domain components there. And then our range components would just be the set of output components. So 9.1, 6.7, 10.7, looks like we have 13.2 and 21.2. So we have that. And that's just going to be the set of our domain components right there. So what I'd like to do is define now what a function is. And so what I can tell you is a function is a correspondence from a first set called the domain to a second set called the range. So in other words, a function is a special relation. Okay, we're about to tell you why it is a special relation. So the same thing, we just got done talking about it, but it maps domain elements to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. So we say functions are 1 to 1. And what we essentially say are 1 to 1 basically means that every x value is allowed to go to only one y value, or every input is only allowed to go to one output. So we would say, looking at these two relations down here, it says determine whether each relation is a function. Well, we'll take a look at this first one. 1 goes to 6, 2 goes to 6, 3 goes to 8, and 4 goes to 9. I don't notice that any of these input values go to more than one output. And when we represent this as a mapping, you can see that everything on the left over here in the domain only maps onto one element in the range, okay? Whereas the second one right here, I say 6.1, 6.2, I've already pinpointed an input value that actually proceeds to go to two output values. And so 8.3 and 9.4 might be a part of this relation, but the fact is that the only one here that is a function is the first one here. Even though these two are in there and they're fine, we have something that is not 1 to 1. So we say that this is just a relation. It's not a special relation that we call a function. We can see that we had an input go to more than one output. So just to talk about why we want functions to be 1 to 1, imagine a time and temperature situation. If you had time of the day go to more than one temperature, it would seem kind of an absurd thing. You know, at 8 o'clock it was both 10 degrees and 20 degrees. So that's what a function is. It is 1 to 1.